Dear students, today we'll see positive feedback used in waveform generation, that is oscillator circuits. So, a topic will be positive feedback in waveform generators. Contents of the topic will be, first we will see what is a feedback. Second, we'll see what are the types of feedback. And then in that we'll see what is, in short, negative feedback, and then we will elaborate what is positive feedback. And then in a positive feedback, we will see what are the conditions required for sustained oscillations, which are called as Barkhansen criteria or Barkhansen conditions. So first, let's start with what is a feedback. So if you see the a concept of feedback here. Now here we have shown there is an amplifier, and the amplifier is connected with a feedback circuit. Now this is your amplifier, okay, and here is the input for the amplifier, okay, and here will be your output of the amplifier. Now this amplifier output is connected back with a feedback network to the input, okay. So this is called as a closed loop. This is called as a closed loop, okay. Whenever output is connected back to the input is called as feedback. Now here the amplifier will give you amplification, it will give you gain, okay, and the feedback circuit, because it is made up of passive components most of the time, it will give you loss, okay. Now in this closed loop circuit, in this feedback, if the feedback goes along with the input, if it is in phase with the input, then it is called as positive feedback. If the feedback is out of phase with the input, then it is called as negative feedback. So that is what we have studied when we studied feedbacks for amplifier also. So after that, here you can see in another diagram, we can show that the feedback can become positive or negative here. It can aid with the input or it can oppose the input. If it is aiding, it is helping the input, then it is called as positive feedback. If it is opposing the input, if it is out of phase with the input, then it is called as negative feedback. Okay. So here, the main two are concepts of positive feedback and negative feedback. Okay. So first we'll, in short, see what is negative feedback, and then we'll go to see what is positive feedback. Okay. So introduction to feedback, as we have seen, the phenomena of feeding a portion of the output signal back to the input circuit is known as feedback. Feedback are of two types, negative feedback and positive feedback. So in negative feedback, what happens? Now here, say this is your input wave, whatever you're giving as input. So this wave you have drawn as this positive half cycle and negative half cycle. Now the amplifier here, whatever you are having, will introduce a phase shift of 180 degree. That means this waveform becomes negative and positive. So positive becomes negative, negative becomes positive in amplified version. So it is a 180 degree phase shift. Now then that output which is taken as a feedback is going to go to the input here. And here the feedback network is not changing any phase. It is introducing zero phase shift only. That means still here it is 180 degree out of phase with the input. So this goes on with this input, then it is a negative feedback. So the input and output is having a phase difference of 180 degree, and this is negative feedback. This might reduce the gain. This can reduce the gain of the amplifier, but it will reduce the losses. And it is good for a circuit to be built as an amplifier. If you're using amplifier as an amplifier, then for a closed loop configuration, you should have a negative feedback. So when the feedback energy, that is voltage or a current, is out of phase with the input signal and thus opposes it, it is called as negative feedback. The amplifier introduces a phase shift of 180 degree into the circuit, while the feedback network is so designed that it introduces no phase shift, that is zero phase shift. The result is that the feedback voltage that is, if you name it as VF, is 180-degree out of phase with the input signal V in. That is why it is called as negative feedback. Then negative feedback is also called as degenerative feedback. Now, in negative feedback, the feedback energy, that is voltage or current, is out of phase with the input signal and thus opposes it. Negative feedback reduces gain, as I've told you earlier. It also reduces distortion, noise, and instability. So the circuit will become more stable if you are using negative feedback, and that is good for amplification. This feedback increases bandwidth and improves input and output impedances. Due to these advantages, the negative feedback is frequently used in amplifiers. So here we have spoken that negative feedback is a feedback which is used for amplifiers. Now, if you're using a circuit called as an oscillator, so oscillator is a circuit which will produce oscillations, repetitive oscillations. So there you have to provide the amplifier with positive feedback. So we have to go to see then what is positive feedback. So here if you see this diagram shows you what is positive feedback. So here you can see the input waveform here. So this is the input waveform. If you draw it, you are having positive half cycle, negative half cycle at the input. Then it will go through the amplification where the amplifier will amplify it, and output will be a 180-degree phase shifted. That is, positive will become negative and negative will become a positive here. Then as you give the feedback to the input, output when it is connected to input, the feedback circuit, this circuit has to introduce another phase shift of 180 degree. So this 180 degree and this 180 degree together will make the phase shift as 360 degree. So that 360 degree is nothing but 2 pi. It will be equivalent to your 0 degree. So that means the feedback voltage will be in phase with the input voltage. That means the feedback is helping or aiding the input. Okay, so it is called as positive feedback. So this concept is called as positive feedback. But for positive feedback, what are the disadvantages is the gain will go on increasing. Okay, so the noise will go on increasing, distortion will go on increasing. But then what is the advantage? Advantage is that you can use this positive feedback as an oscillator circuit. So when the feedback energy, voltage or current is in phase with the input signal and thus helps it, aids it, it is called as positive feedback. Both amplifier and feedback network introduce a phase shift of 180 degree. The result is a 360-degree phase shift around the loop, causing the feedback voltage Vf to be in phase with the input signal Vin. This is what happens in positive feedback. The positive feedback increases the gain of the amplifier. However, it has the disadvantages of increased distortion and instability. Therefore, a positive feedback is very less employed in amplifiers. One important use of positive feedback is in oscillators. If positive feedback is sufficiently large, it leads to oscillations. As a matter of fact, an oscillator is a device that converts DC power into AC power of any desired frequency. So when we use this circuit as an oscillator, we say that there is no specific input for the circuit. The DC supply applied for the circuit will be converted into AC, and that also in a desired frequency. Okay. So here a positive feedback is also called as a regenerative feedback. In a positive feedback, the feedback energy, that is voltage or current, is in phase with the input signal and thus aids it, helps it. Positive feedback increases gain of the amplifier, also increases distortion, noise, and instability. Because of these disadvantages, positive feedback is seldom employed in amplifiers. It is less used in amplifiers, but the positive feedback is used in oscillators. This is the conclusion of what is positive feedback, and it is used in oscillators. Now, what are the Barkhansen criteria for the circuit to produce sustained oscillations? Now, here if you see, this is your input given here. So here is your input, whatever you are going to give to the amplifier circuit. This is your amplifier circuit. Okay, amplifier circuit, which will have a amplification factor, that is its gain will be say A. Okay, so its gain is A. So here the output will be V out. V out. Now that V out will be nothing but V out will be equal to, okay, the gain of the amplifier into input, the gain of the amplifier into input. Okay. Now, similarly, when this output is connected to a feedback network, okay, so this is your feedback network, feedback network. Okay. Now the output of feedback network will be referred as VF. That voltage will be going and helping the input, it will be in phase with the input, and therefore we'll call it as positive feedback. Now this VF, whatever you're going to get, that is the feedback voltage, can be given as your factor beta, that is of the feedback network, multiplied by V out. So it is the gain of the feedback. So gain means the feedback most of the time will produce loss. So that multiplied by whatever output you're going to take of the amplifier here. So that multiplied by this factor, okay, will be the feedback voltage VF. VF will be equal to beta into V naught. Okay. Now you substitute what is V in from V out from here. If you see what is V out, so VF will be equal to beta A into V in. Okay. So here you can rearrange this equation as VF, that is feedback voltage, will be gain of the amplifier multiplied by the gain of the feedback network into V in. Okay. Now, if you want VAF, that is the feedback voltage, to be equal to V in, then this factor should be equal to 1. This factor should be equal to 1. Okay, that means the gain of the amplifier multiplied by the beta factor of the feedback network. Okay, that product should be equal to 1. This is one of the first condition for to get sustained oscillations. And the second condition is that the feedback loop, like as we have seen in a positive feedback, the amplifier will produce a 180-degree phase shift here, and the feedback network also will produce 180-degree phase shift here. So this feedback will be of 360-degree phase shift that will be in phase with the input here, and then that input is going to help, that feedback is going to help the input, so it will be called as positive feedback. Positive feedback. Okay, so here once the input is given starting, okay, after that the circuit will work only on the supply voltage, only on the supply voltage. That is the DC supply required for it. Okay, that is why there is no need of input for an oscillator circuit. So here if you see different types of waveforms I've shown, oscillations. So growing type oscillations. Now this will be oscillations if you take your product, that is gain of the amplifier, into the feedback factor greater than 1. This will be underdamped decaying oscillations if gain of the amplifier beta factor is less than 1. And this will be a sustained oscillations, good type of oscillation, sustained oscillations. This will happen when amplifier, that is the amplifier gain into the feedback factor, is equal to 1. Okay, so this is what is the one of the condition of your Barkhansen criteria. So you get sustained oscillations like this. So in the end, we can conclude the Barkhansen criteria. In order to produce sustained oscillations, following a criteria should be satisfied. Number one, the total phase shift around closed loop should be 360-degree or 0-degree. That is a total phase shift afforded by the circuit as signal proceeds from input terminal to output terminal to the feedback network and back to input terminal is 360-degree or 0-degree. And number two, oscillations will be developed only if the product of magnitude of gain of amplifier, that is A, and feedback factor of the feedback network, that is beta, that is A into beta, that product should be unity. Hence, for sustained oscillations, A into beta should be equal to 1. So these are the conditions given by Barkhansen so that the circuit produces sustained or undamped oscillations. Okay. Thank you, students.